So the problem we're going to look at is this one. Given that z is equal to 3 cos 1.5 plus I sine 1.5, express 1 over z in polar form. Now, the personal vision we have as to what the solution can be must include us considering what the definitions are so that we have a clear personal description of what this problem is. And I believe the main thing that we need to consider here is the construct of the polar form. There is a polar form required. It's a bit of a strange one, really, because some would very much point out that this here is a polar form. That is a polar form. And so really what it's saying is that z is in polar form as described here. Can you make 1 over z the same? That's the first thing that we need to do. And we're going to use, as always, we're going to use logic and reason and related knowledge in order to get there. It's going to be a fraction, so part of our vision is clearly going to have to utilize the kind of mathematics in complex numbers that deals with fractions. So the first thing that I shall do is to take a look at this here. 1 over z must be 1 over 3 cos 1.5 plus I sine 1.5. That is obvious given that we have been given what z is, and we need to simply just do 1 over it. The next stage then, in terms of what the consistent next stage can be said to be, is to recognize that once you have a complex number such as this in polar form in the denominator, one of the mechanisms to simplify such a thing is to make sure that you multiply the numerator and denominator by the complex conjugate. So that is to say cos 1.5 minus I sine 1.5, cos 1.5 minus I sine 1.5 on the top. The numerator there's nothing we can do about. We can take this 3 and therefore this hidden 1 on top and factorize it out, giving us this 1/3 here. So that is why that 1/3 manifests. The question then can be, what is the mathematical outcome of this? That is to say, what is cos times cos 1.5? That's cos squared 1.5. Then we'd need to do cos 1.5 times minus I sine 1.5, which would therefore lead to minus I sine 1.5 cos 1.5. And because very quickly afterwards you will see that you'd have plus I sine 1.5 times cos 1.5. Notice that this part here and these multiplied out will cancel each other, because you'll have a minus I sine 1.5 cos 1.5 and a plus I sine 1.5 cos 1.5. Those two cancel, so they're not included in my next step here, where so far we'd only have the cos squared 1.5 from the first step. Next, then, we'd have to do I sine 1.5 times minus I sine 1.5, which would give us minus I sine 1.5 squared. Now, I times I we've talked about in the past, in which you can see the algebra here. I'm not going to go through this, well, not really, I suppose. Just simple indices laws here. I'm going to go through this in this one. Please see past videos for more detail. But I times I is minus 1. And if you pause the screen, I've given enough steps here that you might be able to rejig your memory without having to go back through past videos. Regardless, I times I is minus 1. And so when you get a minus I, that's a minus 1, which is a plus 1, and then I said it was sine 1.5 times sine 1.5, which is sine squared 1.5, leaving the denominator as cos squared 1.5 plus sine squared 1.5. The numerator does not change, it's still cos 1.5 minus I sine 1.5 as shown here. There's no change in that. There's nothing we can do about that numerator. That is just what it is. Hence, that is why it is the same here. The denominator can be simplified further in terms of cos squared 1.5 plus sine squared 1.5. The abstraction is cos squared theta plus sine squared theta, for which you know the answer to that one is that cos squared plus sine squared is equal to a squared plus b squared divided by c squared. In other words, opposite over hypotenuse squared plus adjacent over hypotenuse squared is simply going to be adjacent plus opposite squared, which is the same as the hypotenuse divided by the hypotenuse squared, and hypotenuse squared divided by hypotenuse squared is 1. So this one here, again, if you wish to go through that a little bit slower, you can pause the video, come back, but generally sine squared plus cos squared, utilizing this Pythagoras' triangle, you can see that the numerator is c squared and the denominator is c squared, and c squared divided by c squared is 1 is another way to view that. So therefore here we can say that all of this down here, all of this here, if I were to allow this to manifest an arrow, that is simply going to be 1, meaning that we only left with the numerator, as the denominator is 1, the 1/3 that we had from the beginning, and so the answer is 1/3 cos 1.5 minus I sine 1.5. Now the question when you find yourself coming with producing a solution is there any alternative solution? Is it in the best form of the solution? And I think the answer here is there is not really an alternative other than to expand out the 1.5, which is definitely not necessary here. That is the most simplified it needs to be. And in these circumstances, this is its polar form. So that is the solution to that one. Let's take a look at the second problem. The second problem says given that Z1 is equal to 4 cos 2.5 plus I sine 2.5 and Z2 is equal to 6 cos 2.1 plus I sine 2.1, can you express Z1 over Z2 in polar form? Same discourse, same situation. It's now that we have a Z1 divided by Z2 and it needs to be in this very simplified polar form being R cos A plus I sine B. So we need to do that here. Now, when we're looking at this next part, I'll make this nice and clear. One of the things I do straight away is I simply write out Z1. Z1 is this here, and Z2 is that there. I've taken that simply from Z1 being that, and Z2 being that, and then just doing numerator divided by denominator equivalently. 4/6 is the same as 2/3, so I'm going to pull out that 2/3 from the beginning, and so my final answer will have that 2/3 at the as a coefficient to the polar form. Now, this is going to be the same pattern as before, so I'm going to skip a little bit of the steps. I don't do that much, but because I'm also aware of engagement with regards to these videos, and I've gone through how I did it in the last section for the earlier part of multiplying the top and bottom by the complex conjugate, I'm skipping a little bit. What I do show, however, is notice that given that the denominator is something like cos 2.1 plus I sine 2.1, the complex conjugate must be cos 2.1 minus I sine 2.1, and I'd multiply top and bottom by them. From this point, then, I'm going to do multiplication. The numerator is going to be cos 2.5 times cos 2.1, then cos 2.5 times I sine 2.1. Finally, I will do I sine 2.5 times cos 2.1 and I sine 2.5 times minus I sine 2.1, and that will be the numerator. The numerator I have not multiplied out yet in the next step, however, I simply just keep it in this form. As you can see, it's exactly the same form. I've not really done anything with it yet. I'm not going to multiply that out yet. I'm just describing what I'm going to do in a moment. The denominator is exactly the same process as before. So I'm going to bring in the earlier question when I said the denominator, if you can take a look at the last question, is I had cos 1.5 times cos 1.5. That produced cos squared 1.5. I then said that when you have the I sine 1.5 times the cos 1.5 and this minus I sine 1.5 also times the other cos 1.5, they cancel each other out. The same thing will manifest here. I'm going to get, let's get a nice clear color here, cos 2.1 times cos 2.1 will be cos 2.1 squared. I will then have cos 2.1 times I sine 2.1. That's a negative I sine 2.1, so it would be a negative. But then there'll be a positive cos 2.1 times I sine 2.1, so those will cancel. And finally, what will be left is, as before, plus I minus sine 2.1. And as described before, I times I is minus 1, and the minus signs cancel with that minus 1 to get a plus 1, which will leave me with a very similar denominator to this one. It will be a cos squared 2.1 plus sine squared 2.1, which, using the same rule, is 1, meaning that the whole denominator, this section here, all of this, will cancel down or can be expanded, and then utilizing the Pythagorean rule for trigonometry, all of this simply becomes 1 and 1 alone. So that is what the denominator is. Hence, what you will notice is in the next stage of this conversation, you will see that I've got rid of completely the denominator. There is no denominator here, there is just the numerator. Then I multiply the numerator out as described, cos 2.5 times cos 2.5. You will see that cos 2.5 times cos 2.5 manifesting from there. Then I would do cos 2.5 times I sine 2.1, which technically can be found there. That's the cos 2.5 times I sine 2.1 with a negative. Then there's the I sine 2.5 cos 2.1 that I multiplied out next. That can be found underneath. And finally, I sine 2.5 times minus I sine 2.1, sorry, make sure I get my numbers correct. Apologies if that's caused confusion, would give sine 2.5 times sine 2.1. Now, first thing here is when you see something like this, one of the best mechanisms for progress is simply to separate real and imaginary. That's fundamental. So if we separate real and imaginary, you can see this happening underneath. The real part is the cos 2.5, cos 2.1 here. Then there is a sine 2.5, sine 2.1 there. That is the real. Let's use, for example, the color red to illustrate the reals coming together. The imaginary parts are all those with the I in front. I can factorize out I, leaving me with sine 2.5 cos 2.1 there. And I can also factorize out the I, but this time it will leave me minus cos 2.1 sine 2. Cos 2.5 sine 2.1 there. So that is simply separate real and imaginary. At this point, the next thing we're going to employ, and please see past trigonometry videos on double angle formula as to the following rule, which is these, which represents two right angle triangles sat on top of each other, wherein the angle, for example, x would be doubled. If I were to use accurately my capacity to sketch things on here, do apologize that it won't be as accurate as it probably should to demonstrate this point. If you place another right angle triangle on top of the right angle triangle such that the angle in here is 90 degrees, so that that in there is 90 degrees, then the angle in here is said to be the double angle. It will be an x plus, for example, an x plus y. And there are certain rules that manifest as a result of a little bit of trigonometry, some very basic algebra I would describe, that leads you to sine x plus y is equal to sine x cos y plus sine y cos x. Sine x minus y is equal to sine x cos y minus sine y cos x. The main one that we shall see, the cos x plus y is equal to cos x cos y minus sine x sine y, and so on and so forth. Let's utilize them by, if you take a look at these, you can see how these patterns manifest here. You've got a cos A, cos B, plus sine A, sine B. And there I can suggest to you that if that is A, notice how it's the same A there. And if this is B, notice how that is the same B there. That is to say that this is the same pattern that produces cos A minus B. Notice one more time, cos A minus B is equal to cos X cos Y plus sine X sine Y. This is going to be utilized to simplify all of this down here. And I do think that in the past I might have said that x plus y was the one that I was going to utilize. My apologies, it is definitely the x minus y, or x. Sometimes I use a and b, that's just from habit. It's either way. So that is to say cos a minus b is cos a cos b minus plus sine a sine b. So generally speaking, that's what causes this. With regards to this, you can see the same thing manifesting here. For this right term, what we can see is that you have a sine x cos y minus cos x sine y, or sine a cos b minus cos a sine b. This is exactly the same in terms of this one, sine x cos y minus sine y cos x, or sine x cos y minus cos x sine y, which you could simply write as this, sine x minus y. So hence that is what's been done. You have this section over here has been written as sine x minus y. And therefore, we can suggest that that is the most, or one of the most simplest ways, so we can write this line of mathematics here. We can go further though. 2.5 minus 2.1 is 0.4, and therefore our solution in its best form can be said to be 2/3 cos 0.4 plus I sine 0.4 there.